Alright, so go to the folders folder of the programming enrichment page on Edmodo and go to Project1 Save Mario. I'm making this video right now, so it's not up here, but you'll also see this video in this folder. But the first thing you want to do is you want to download the project. So the last project, or in the last project, you created your own program from scratch. In this project, I'm going to provide a lot of the programming for you and ask you to accomplish a task using some predefined methods or commands, and let's see how you do. So click on Save Mario, and that's going to ask you. Some of you will have this pop-up window. Others will have a different window. However your particular operating system works, you'll be able to download the file. Just follow the instructions on the screen. So I'm going to save the file, and I'm going to press OK. Alright, and it's going to download the file. And just like before, when you downloaded CodeBucket, what you're going to do is you're going to go and you're going to find your Downloads folder. Follow the instructions step by step and you shouldn't have any problems. Look at your Downloads folder, and inside your Downloads folder you should see what's called a zip file. A zip file is a compressed file. It's essentially a lot of data that's been compressed. It's hard to explain what compression is right now, but it's taking a lot of data and representing it in a way that takes up less space. I mean, it's literally like you take a sponge and you compress it so it takes up less space. You can do the same thing with files. So to uncompress it, you just double click this and your computer should automatically uncompress it into a little folder that says Save Mario. Some of your computers will do this automatically. The important thing is you should eventually, what you want to do is you want to drag this folder, not this compressed file. If you see this file, if it looks like this, you're not done. If it looks like this, then you're done. All you have to do is you have to take this folder and you drag it to the desktop, and now it goes, you've moved it from the Downloads folder over to your desktop. And you can close out Edmodo, you can close out everything. Now, a lot of you are going to mess up on this step, so pay attention and follow these instructions step by step and you won't mess up. Open up CodeBucket. Go to the Projects folder. You must go to the Projects folder. You cannot do this. If you take Save Mario and you put it there, nothing's going to happen. So, open up the Projects folder and you should see a bunch. I mean, eventually you'll have a bunch of projects, but right now there's no projects. You can just take Save Mario and put it in your Projects folder. And now, how many projects do you have there? You've got one Saved Mario. In fact, some of you might have, or you should have, at least one or two projects in here because you created a project in order to do Project 0. So, now inside of your projects folder, you should have at least Save Mario in there. You go to codebucket.jar, which is the program. You open it up, and we're going to start our project. Load project, you're going to load Save Mario. And you go to Save Mario VGPC. You open that up, and ta-da, here's the Save Mario project. Now, in the last project, I taught you how to use the display and the window commands, or the methods. We're not going to do that in this project. Whenever you're building a program from scratch, you are going to deal with the drawing on the screen. However, when I give you a project, I'm going to give you some user-defined methods. I've created these methods. I've done the programming. You're just going to use these methods to accomplish a certain task. And if you think that that's kind of too easy, I'm doing stuff for you, a lot of programming is using other people's commands to accomplish something. So for example, when I programmed this program, I did not program this window. You see this window and how it functions? I didn't do that. I could, but there's no reason to do that. Someone else programmed a window, and I'm just using their window. So I created all of these methods, and you're going to use them because that saves a lot of time. So let's start with the first method. I want you to use set window size. What do you think that does? Well, it sets the width and the height of the viewable window. All right, which is very much like set size that you used before, except this time I am giving you the method, and I'm doing that for a specific reason, and I want you to learn how to read this documentation and figure out how to use it. So we're going to set the size to 500, 500. All good. So now I'm going to run the program and see what I get. Should get a window that's 500 by 500. Okay, great. I've got an empty window, and I've got a box that says Start Here. Well, that's kind of weird. This doesn't seem very interesting or fun. So let's go to this second method. It says Show Grid. What does that do? Well, description, draws a grid. Okay, that seems interesting. I'll put Show Grid down there, and I'll run the program again. And now I should get a window that's 500 by 500 pixels, and I should get some kind of grid. Yep, there's a grid. Now, what do you think this grid does? Well, let's analyze it. Let's see. There's big boxes and small boxes, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 boxes across. 10 big boxes across, and each box has 5 little boxes. So if the whole window is 500 pixels wide, and I've got 10 boxes with 5 little boxes inside each of the big boxes, what do you think is what do you think the size of each box is? I'm guessing the little boxes are 10 pixels by 10 pixels, and the big boxes are 50 pixels by 50 pixels. Why is this important? Because I can easily locate any coordinate on the or inside the window. So let's start from 0, 0 up here. Let's go down one box. That's y equals 50, 100, 150, 200, 250, 300, 350, and then that's 360, 370. Y equals 370. And then I'm going to go over 1, 2, 3, 4, 5. That's 50, that's 60, 70, and then this point right here is x equals 80 and y equals 370. That was easy to find. Rather than the trial and error of your last project, you're going to use a grid to know exactly where you want to draw something. All right, so we know that this point right here is, what do we say? X equals 80, y equals 370. Okay, good. Now we know how to use the grid. Let's go to draw board. What does that do? Notice, you don't need me to tell you any of this. You can read about what these things do yourself. Draws the board using the specified color. If this method is not called, the board will not be visible. And it takes one parameter, an integer called color, and the color is a value 1 through 12 that determines the color of the walls. And that uses the same color key that I gave you last time. So you can choose the color of your board. I'm going to choose blue, so I'm going to use 5 because I like blue. Draws board, and I'm going to draw it blue, and let's run the program, and I should get a board with a grid. There we go. Ooh, pretty. Okay, so now I've got a board, now I've got a grid, now I've got a window. What else do I need? Well, I'm going to save this for later. Let's skip wait for spacebar, and let's skip draw Mario coordinates, and let's go right here to draw Mario at. So I'm going to draw Mario at a certain coordinate. Let's choose 50, 50. I don't know. Let's just try something. And there we go. I've drawn Mario at 50, 50. X equals 50, one box over. Y equals 50, one box down. Notice the origin is hidden by, oh, I forgot what this is called. I think this is called the dressing of the window. This is about 22 pixels or 30 pixels high. But the origin is over here. There are some pixels hidden. But so this is coordinate 50, 50. But that's not really where I want Mario, right? I want Mario to start where? Right there, the start here box. And we figured out that this was y equals 370 and x equals 80. So we don't have to do much thinking here. We just have to plug in those coordinates, x equals 80 and y equals 370. And I'm going to run the program again. And there we go. I've got Mario at the starting point. Now, as you may have guessed, your job is to move Mario through the maze, through this diagonal, all right, over to this warp zone, exactly on that warp zone. All right, and then if you notice, there's no way to get from here over to this little place. So he's going to have to somehow jump from this box over to this box, or this location to this location, and then move to the home base. And if you get Mario exactly on home base with those exact coordinates, you'll see what happens. Nothing really cool, but you will save Mario. So let's begin to move Mario through the maze. The first thing I want you to do is, if you put draw Mario's coordinates anywhere, let's put it right before we draw Mario at, notice what this does. It displays Mario's coordinates at the bottom of the screen and adjacent to Mario's position. This is not necessary, but it's a helpful tool to let you see exactly where you are. So there we go. I know that Mario is at x equals 80 and y equals 370, and I can see it right there. And Mario's being drawn right at that point. So it's important to understand that although you're drawing Mario here, he takes up 50 by 50 pixels of space. Why is this important? Well, let's try and move Mario through the maze. So we're going to use Move Mario 2, which is kind of intuitive. It moves Mario to the specified coordinate. So I'm just going to move him to, I don't know, 500, 500, and let's see what happens. I'm going to run the program, and boom! I tried to move Mario from this location to 500, 500, which is right here. And there was a wall in the way. So I hit a wall, there was a collision, and I lose. I did not save Mario. Tears, tears, tears. So, let me try, well, before I do that, let me plan out where I want to move Mario to. So I think the easiest thing at this point would be to move him horizontally over to a coordinate right about here. And since I know the y is staying the same, the y is still going to be 370. So what's x? This was 80. That's 100, 150, 200, 250, 300, 350. Let's do 360, 370, 380. Let's do 380. Actually, let me demonstrate this. Let's do 390. Let's do 400. All right? That seems right. We can move Mario here, but remember I told you he takes up 50 by 50 pixels of space. So watch what happens if I move him to, what was that? X equals 400, Y equals 370. And I'm going to run the program. And there we go. And I'm going to move him. Look at that. I moved him to x equals 400, but because he takes up 50 pixels of space, the right side of Mario collided with the wall. So that's too far. So I'm gonna not move him to 400. I'm gonna move him to 380. X equals 380, and that should give me enough space. And there we go. All right. Now I'm on my way. All right. I can move Mario up, and then over, and then up, and then through the diagonal, and then into the warp zone, jump or change Mario's position from this box to this box, and then over to home base. And there's only one more method that I want to show you. There's wait for spacebar, and if you read what it does, it pauses the program until the user presses the spacebar. Sometimes you want to break. You want to tell the computer, wait a second, stop following instructions so I can think about what's happening, and then continue once I say. So wherever you put wait for spacebar, let's say you put it right here, between draw Mario at and move Mario to, the computer's going to follow the instruction draw Mario at, and then it's going to wait for you to press the spacebar until it moves to the next instruction. This way, you can move Mario through the maze step by step, analyzing each movement and seeing whether or not that's really what you want to do. So right now, if you notice, Mario's not moving. The computer drew Mario at a certain coordinate, and it's waiting for you to press the spacebar until it follows the next instruction, move Mario to. And ta-da, it moved Mario to the next coordinate, or it followed the next instruction. So you've got everything you need to know, or you know how to do everything you need to in order to save Mario. I'm not going to tell you anything more. Good luck. I will tell you this. Let's see, 1, 2, 3, 4, 5, 6, 7. All of this can be accomplished in 7 moves with 1 jump, and um, many people have trouble with this diagonal. I encourage you to think about the most efficient way to do that. It does not take more than 1 instruction to get through this diagonal if you think about it correctly. And a lot of you are my geometry students, so all I'll say is think about some parallel lines. All right. Good luck, and I'm here to help you if you need it.